Now that we know how to make ionic compounds, and we understand that sometimes nonmetals form covalent chunks that have charge to make polyatomic ions, let's consider how to make ionic compounds containing polyatomic ions. The first step is to recognize the ion and its charge. So I look at my periodic table to find calcium ion. I see that calcium is a main group element and it's an alkaline earth metal, and they form +2 ions. That's a way that calcium metal can become stable, by losing 2 electrons to be isoelectronic with argon. So the charge on this calcium ion is 2+. Nitrate ion is going to be an ion that we just have to memorize. And you can find those in the chapter on a table called Some Common Polyatomic Ions. So I look on that table, or I've already memorized that nitrate is NO3 minus 1. So calcium has a +2 charge. Nitrate's a -1. We're going to need 2 nitrates to balance that +2 calcium ion charge. Because nitrate is a chunk, we can't just write it this way. Calcium, the cation goes first, it's on the left on the periodic table, and then nitrate, and say 2 of those, because it looks like we have 1 calcium, 1 nitrogen, and 32 oxygens, and that's not what we mean to say. What we mean to say is 1 calcium and 2 nitrates. So what I need to do is use parentheses to group the nitrate into a chunk when we have more than 1 in a formula. Okay, ammonium ion. Ammonium is one of the polyatomic ions that we're going to memorize, and it is the only cation. Ammonium ion has a +1 charge, and so does nitrate. So because we're going to use 1 of each ion, there is no need for parentheses. And we write them that way. We keep the ammonium as a chunk and the nitrate as a chunk. I have seen students want to do something like this. Let me just, put this back. Ammonium with its +1 charge and nitrate with its -1 charge. And when they're in a formula unit, in the unit for the formula, we hide the charges. I have seen people want to combine nitrogens, but that is not appropriate. We're keeping the chunks together, and there's reasons for that we'll talk about later in the semester. Okay, so here I have iron 3. Why do I need to be told that it has a +3 charge? Because iron is here on the periodic table, and it's in that area that we think of as the unknown zone, the transition metals, where most metals have more than 1 charge choice possible. So we say there are variable charge choices. And for iron, the choices are +2 and +3. So we have to be told which one we're using, or we don't know how to put the pieces together to come up with a formula. So here we have iron 3 and nitrate's a -1. We're going to need 3 nitrates to balance that +3 charge. Okay, another polyatomic ion, but it doesn't seem polyatomic because poly means many and there's only 2 elements, but hydroxide is considered a polyatomic ion. Hydroxide has a charge of -1, calcium has a charge of +2. We're going to need 2 hydroxides. So here's a mistake. Excuse me. Here's a mistake that I do see fairly often, and that is But that's not what we mean to say. These are not the same thing. Here we have 2 oxygens and 2 hydrogens, or we could say 2 hydroxides and 1 calcium ion. But here we have 2 hydrogens and only 1 oxygen and 1 calcium. So those are not the same thing. Okay, ammonium ion is has a +1 charge. Hydroxide has a -1 charge, so we put them together in a 1-to-1 ratio. Ammonium, but hide the +1, hydroxide, and hide the -1. Ammonium hydroxide. Okay, iron 3 hydroxide, we're going to need 3 -1 charged chunks to balance that +3 charge. Sulfide is on the periodic table. Here is sulfur. Sulfur is in group 6, and to be isoelectronic, it needs to be like one of the noble gases, the nearest noble gas. Sulfur has 16 protons, and an atom would have 16 electrons, but if it can gain 2 electrons, it'll have a -2 charge. So 16 protons, 18 electrons. Like every nonmetal in group 6, it can become stable by having a -2 charge, 2 extra electrons to be isoelectronic with the noble gas. Okay, 1 calcium, 1 sulfide. They come together in a 1-to-1 ratio. Ammonium, we're going to need 2 ammoniums because ammonium has a +1 charge. So 2 ammoniums plus 1 sulfide. Because this is a polyatomic, we have to put brackets around it and say, put the 2 here. Okay, iron 3 sulfide. So now we have a +3 charge and a -2 charge. We look for the lowest common multiple, which is 6. We'll need 2 iron 3s to add up to +6. And 3 sulfides to add up to -6. So iron 3 is not a polyatomic ion. It has 2 letters, but only one is capital. So even though I need 2 iron 3s to go with my 3 sulfides, I don't use parentheses. Okay, let's go the other direction. So before, we were building our compounds, but now they're built, and we're going to name them. So it gets kind of confusing because of all the letters and numbers, which is why it's super helpful to have memorized the polyatomic ions or to have that handy as you go through this problems like this. So I recognize sodium. I expect for an ionic compound to see the cation, which is typically the metal. The only cation that is not a metal ion is ammonium. So I typically expect to see the metal on the left, and I separate it and look at everything else. And then I recognize this chunk. You may not at first, but I've had students in the past that said things like, ooh, I love nachos. A big plate of nachos with lots of cheese. And so they built a picture that looked like this. Stacked high with nachos. Nacho. A big 232 big chunk. And then somehow in their brains they connected sodium acetate with nacho and have never forgotten the order of these letters or what numbers go with them. So if you need help thinking of ways to remember, like acetate is CHO and 232, just ask. I probably have had some clever students in the past that can help us out. Okay, so this is sodium and acetate ions, and there's one of each. Not that that matters here, but sodium acetate. Okay, so same thing. First I decide, is this ionic? Yes, it is, because silver is a metal, and there's two silvers. So let me break this apart. I have silver, and silver always has a +1 charge. So here's silver. And zinc and cadmium, even though they're in the unknown zone, they're transition metals, they always have fixed charges. So I remember silver has a +1 charge. And here there are two of them. So we have two silver ions and then a chunk of charge, CO3. And it must have a 2- charge for it to balance two silver ions. And then I remember, oh, that's carbonate. So here we have silver carbonate. It's much easier to name things when you're familiar with the polyatomics so that you recognize them when you see them. Do I say silver 1 carbonate? No, because the only charge choice for silver ion is +1. Okay, so is this an ionic compound? Yes, it is. There's cobalt. But cobalt is in the unknown zone. And I know the possibilities for cobalt are +2 and +3. Which one do we have here? Well, here's acetate, and acetate has a -1 charge. There's two acetates, so this must be cobalt 2 ion. So the 2 here means +2 charge, and two acetates, cobalt 2 acetate. So for these ionic compounds, we're never saying the number of ions. We didn't say anything about there being two silver ions. And what we're referring to here is the charge. The charge on the cobalt in this case was +2. Okay, this looks like an ionic compound because it starts with zinc. And zinc has a fixed charge. Zinc has a fixed charge of +2. So I'm not going to state the charge because there's only one possibility. And then this chunk of charge, PO4, and I've just memorized 3-, that's phosphate. So here we have a zinc phosphate. I don't say zinc 2-phosphate because the only possibility for a zinc ion is +2. Okay, is this an ionic compound? Well, yes, it starts with lead. Lead has two charge choices, two possibilities. Lead could be +2 or +4, just like tin. Which one do we have in this instance? Let me look at what else we have. And then I recognize sulfate. Why? Because I've memorized it. Do you really have to memorize these? Yes, it really helps. And if we were on the ground, absolutely. Okay, so sulfate has a -2 charge. And I have one lead ion and one sulfate ion making up that formula. So it must be a +2. This is lead 2 phosphate. Sulfate. If I didn't say lead 2, if I just said lead sulfate, would it be wrong? Yes, because there is also the possibility of lead 4 sulfate. And lead 4 sulfate would have 2 sulfates. It would have a different formula, and it would have different properties. Okay, so the last one could be a little bit tricky because it kind of looks like it's a covalent compound. I'm looking at the element on the left. Nitrogen is a nonmetal, hydrogen's a nonmetal, sulfur and oxygen, they're all nonmetals. But then I remember, wait a minute, ammonium ion. Ammonium ion behaves like an alkali metal ion or a group 1 metal ion. So, yes, this is an ionic compound. I have 2 ammoniums and 1 sulfate. So say the cation first, ammonium, and the anion second, sulfate, and we're done. We don't need to say how many of each kind. I don't need to indicate that there's 2 ammoniums or 1 sulfate because we're familiar with the charges, and people who speak chemistry are familiar with the charges. When do we need to indicate what a charge is? When do we need to put a number into a name to indicate what the charge is? That is the only time we put a number in a name. Okay, so nomenclature is important, and you're at home and you have access to your book. I just recommend that you still spend some time in it, maybe make some flashcards. Definitely have your table of polyatomic ions available and a periodic table that you've color-coded so that you can keep track of the charge choices for main group elements and for transition metals. And the more you use it, the better you'll get. Nomenclature is one of those things that any student can do and do well. It just takes practice. It just takes work. Nomenclature is also a thing that if you don't figure it out at the beginning, it will plague you. It will be a problem throughout the semester. So it's really important that you spend time practicing. It's okay to make mistakes. And please email me if you have questions. Thank you for your time.